Hello, hello. Welcome back to this week's episode of Pirates Parley. My name is Steve. I'm known as Steve Klingbrook. That's my handle, but also known as Happy Pirate on X. We're back this week. I had a week off last week, so sorry if you missed me. This week's guest is none other than a person who is really, really good with handling really, really big data sets. He also knows a thing or two about robotics and AI. Please welcome Miles. Yay! Our very own
Hey, thanks.
Miles. How you doing?
Doing well, Steve. Thanks for having me on.
Yeah, most welcome. If you guys have any questions for Miles or me, please put them in the chat. I got it working this week, and also good news. I'm just back from the store. I bought a really really expensive mic, so the audio quality next week will be a lot better. Hopefully, it's not in yet, but it's on its way. So, Miles, you work at Trident One. How's working at Trident One?
I think everybody says this, but for me, it's actually true. And if you follow me on X, you know that I'm not one to mince words if I don't believe in something. Triton's the best place to work. The people that I work with day in and day out impress me with things that I don't know. And yeah, the collaboration is top notch. And we get to work on some of the hardest problems in the world, which is also a lot of fun.
So I brought you on because one of the really big problems we're currently working on is Solana's ledger. It went to many iterations on how we serve old data. So for those who don't understand really what I'm talking about, if you send a transaction in 2022, you still want to know about that transaction. That's what blockchains are all about. But since then, many transactions happened. How do we find that data? How small is the data that we're finding? And how large is the data set that we're finding it in? Those are the things I want to answer today. So let's start with the first things. How did you become interested in handling super large data sets in the first place?
Yeah, so I've always, for the last several years, been interested in Solana simply because of the ledger size, right? The block times cause you to have just a lot of data that is considered ephemeral or transient inside the actual validator, and once it gets past a certain age, it doesn't really exist except for in some really hard and esoteric data sets that you have to know a lot about to get access to. And to me, that didn't really feel like in line with the ethos of crypto and what we all really want to be able to do and to verify that transactions really are what they are and did what they said they did. So yeah, I think that's what got me into it. I got started at Trustless Engineering, which is my firm on the side, working with Old Faithful. It's a Triton project that takes all of the Solana ledger and wraps it up into these content addressable archives that we call car files. And those have the proof of history there, so you can cryptographically verify that the data set is correct. And it was a really good starting place. But I think back in the day when I was getting to it, it was still very hard to work with and understand. And there were some edges that really got difficult to work with. So yeah, I started, chewing glass and fixing the edges.
All right, so you're already way ahead, I think. What is Old Faithful for those who don't know?
Great question. Yeah. So Old Faithful is an open source archive of the entire Solana ledger from Genesis to tip that Triton provides as a public service to the Solana community. So if you ever want to know what happened back in epoch 1, 10, 200, or 700, we have a car file that you can access using other community tools or tools that we've built through a GitHub repo and get access to that free of charge.
All right, that's awesome. So the public ledger is also actually publicly available.
Correct. Yeah, and I think that's one of the biggest things for me is I really need to, in order for me to put my faith in a public ledger infrastructure, I got to be able to see the history, right? If it's not there, it's not quite right for me.
So where is it stored? Where is it? Where does
Yeah,
it sit? And how big is it? And how speak to the imagination. How many movies of data are we talking about, or how many MP3s are we talking about?
Right. So MP3s, man, I think you might be dating yourself there a little bit. Everyone's on streaming platforms now. But if we think about the total ledger size in car files, it's about 400 terabytes today. Uh, Last time I checked, I think each epoch is generating approximately 600 to 800 gigabytes. That's going to be very dependent upon what kind of transactions are flowing through. And then we generate additional indexes on top of that I think also sit around 50 terabytes right now, right? And the indexes are a huge and critical part of it because we're looking at almost 400 billion transactions across the Solana network. I think that's the right number. And if you want to balloon that out to the address interactions, right? So if you take a transaction that has 4 different addresses listed in it, that would be 4 address interactions. That number is up to 4.5 trillion now, and so it just becomes this massive data set that being able to find any one specific piece of information in is a very hard computer science problem, down to the first principles of almost every piece of infrastructure that it touches.
That's a lot to take in. So if I understand this right, every epoch is stored in a file, and that file is how much gigabytes?
Somewhere
800?
between 600 to 800 gigabytes. It depends on the epoch, but yeah, just under a terabyte. Yeah.
And then we have to index all those transactions as well to make sure that we can easily find these transactions.
Correct. Yeah. So in Solana, every transaction that is submitted to the network has what's called a signature, right? This is a generally for humans base 58 encoded string of binary data, and that is unique to that one transaction. Every transaction has a different one. And there's 2 parts of a blockchain, right? There's the writing to the blockchain, but then there's the reading of the result. Writing to the blockchain in Solana does it the best. We have some of the most transactions per second on some of the smallest finality times, and that generates a lot of data and a lot of signatures. So being able to find any single one in there becomes an indexing problem, right? And indexing is really all about how much data can you filter the quickest, right? Reducing the overall data set that you actually need to look at the individual data for.
All right, understood. So where is it stored and how does it work under the hood? Let's say
Yeah.
I'm opening up my wallet and I want to look at a transaction that happened a year ago, or I open the CLI tools and I want to see all transactions that I did, for instance, all the way back to Genesis. How would that work and what happens under the hood?
Yeah, so it's a fairly involved process today that most infrastructure providers have solved through various different means, right? Generally speaking, the flow will go that if you are asking for a specific transaction, it's going to hit a validator first, and we're going to see if that transaction exists sometime in the most recent data set, right? If it does, we're going to return that information to you. It's going to be the most accurate, the quickest out the door, right? If it doesn't, that will usually fall back to what's called the history flow, right? Traditionally, these have been used like large cloud databases or just static files, or sometimes the RPC will even respond to you, "Hey, I don't have that information anymore. Sucks to be you," and you're kind of just left there with nothing to do, right? Now at Triton, we will actually route you to Old Faithful backends or other backends that have indexed this data in different ways, right? And providing those same interfaces, the JSON RPC, gRPC, Yellowstone gRPC interfaces, to access that data so that the end customer, the end user, doesn't really notice the difference, right? That's what I want. That's how I want to interact with my blockchain, is just ask for a transaction. I don't care where you guys keep it, just give it back to me. Storing it's your job. Now, again, that's usually required a lot of infrastructure, a lot of custom code and backend stuff. And so Old Faithful's purpose was to abstract as much of that as possible into a single runtime that you yourself, given the right infrastructure, meaning servers and hard disks, you could run the ledger yourself. And it would provide you a JSON RPC interface that you could make these same get transactions, get signatures for address requests, that would span the entire ledger, right?
So everyone can host this themselves. Everything is open source. All right, that's good.
Absolutely. Yep.
It also adds to the validity of the blockchain, right? Because if all RPC node providers would say, all right, let's just give ourselves a little boost in our own accounts and return that as truth for all blockchain applications, you can basically cheat the history of Solana, or not that critical.
You get a lot of protections from the cryptography, right? So signatures, the proof of history, the block entries, a lot of that will protect you from someone being able to forge the state of the blockchain for any period of time, right? But that really is kind of dependent on you reading the actual blockchain and not reading a third-party provider who may change the data or alter the data in some way, right? If you're relying on that being your source of truth, you're only going to be as accurate as they allow you to be. So I think that's a big thing, is making sure that there's diversity in the number and ways that you access the blockchain. That's a big part of it, right? That's what it's supposed to be, is that you don't have to trust any one provider to stick around, right? If Triton stopped offering Old Faithful tomorrow as a service, everyone in the world could still go to the repo, run it themselves. Their services wouldn't be affected, right?
Nice. Built to last.
Yeah.
Awesome. All right. So let's say we query something. It first hits the back end of the RPC provider, then it goes to an index. It looks up where the data can be found, and then where does the data come from? Where is it stored?
Right. Yeah. So what's great about Old Faithful is that the data is actually stored in those car files. So the indexes that our team has built are offsets to the actual start point of the byte array that entire file comprises of, right? Like start at offset XYZ and then read for n number of bytes, right? And then by us making those indexes beforehand, you can very quickly say, hey, here's a signature. What is the byte offset and the length of that record in that car file? And you can go and read just that section, right? This can be placed on top of things like HTTP range requests, which do a very similar thing of requesting just a segment of a file on a CDN or something. And some of like the work that Sam has done from ANSA on Jetstreamer takes a really good advantage of those HTTP offset ranges to be able to parallelize the number of requests you can make for a single car and ingest it, right? So internally, when we've used Jetstreamer, we have our cluster for our internal next-gen history infrastructure that's got a 50 gigabit shared network, and we were able to pull 30 million transactions per second using Jetstreamer and ingest the entire ledger in about 3 days into our next-gen systems.
That's crazy. That's almost half a petabyte in 3 days.
Correct. Yeah.
Damn. All right. So for those who don't know, any more insight on what Jetstreamer is, what it does?
Yeah, Jetstreamer is really like the answer to, I think, a lot of people's problems that they had with that last mile accessibility of Old Faithful data. It's a tool that you can run, and you can write a specific plugin for it, however you want, and you get notified of basically 2 events whenever it sees a transaction and whenever it sees block metadata, right? And with those 2 events, you can point it at an epoch, and it will just grab as much data as it can from Triton's Old Faithful CDN network and pull it down. It's really going to saturate your network card, your CPU. Something on your side will break before it does on ours.
Buyer beware.
Yeah, we have seen in the past with some explosion in popularity of the tool, we've seen multiple petabytes in a month be pulled down from our CDN network. So people are using it, people are getting the data, and it seems to be working great. So huge shout out to Sam for building that tool. It's a great piece of software.
All right. Do you know his handle by chance, so people can follow him on X?
I do. I will grab that for you here. I don't remember it off the top of my head. It's one of those like XSAM0SOL. I think there
All
might be
right.
a couple extra characters in there, so I don't want to tag the wrong person on accident.
If you're listening in, Sam, please drop your your handle in the comments. Oh, that way. All right. Awesome. So tell me, what are you currently working on? Because we've covered Old Faithful, what it is, what it do. What else do you do at Triton One? Is there anything new in the pipeline?
Yeah, so I kind of hinted at about it in the last little segment there. The some of the edges that we came up with on Old Faithful is that it does very good at what it's designed to do at a certain scale, right? And as we wanted to add additional features to it, adding those additional features became complex. I think mostly because the Solana SDK is changing so rapidly right now. And Old Faithful was originally written in Golang. So we have to transpose every new change from Rust into Golang. So one of the things that I started looking at when I said, okay, how do we take this access from being available to also being performant, was looking at how can we easily add new RPC methods, new ways of looking at historical data that are still performant in an easy way in the future. Anybody else in the ecosystem that is involved in similar problems like this has heard of a database called Clickhouse. It is a very performant OLAP. So if you're familiar with databases, you have OLTP, which is online transaction processing database. It's like MySQL. It's very good at ensuring the data is in there from like an ACID compliance level, right? On the other side of that, you have online analytics platforms or processing. And those databases are for asking analytical questions about large data sets, right? Which is exactly what the Solana ledger is. Every single epoch that we have is immutable data that will never change, right? So by being very careful and crafty and, most of the time just kind of just throwing stuff at the wall and seeing what sticks, you can find really performant ways of querying massive data sets by using Clickhouse as the backing data store, right? And so that's what we've built at Triton. We have a tool that kind of mimics the Old Faithful setup into where you have a data set, an archive, which is the car files in Old Faithful. In Hydrant, we use Clickhouse as our backing data store, right? And Hydrant has an RPC interface as well that manages that translation of SQL data into your JSON RPC layer. A little bit of back history of like kind of the first principles of how we started to approach this is that same kind of approach that the team did with Old Faithful, which is it's an indexing problem. How do we filter the data the quickest that we can, right? And so in Clickhouse, you can do some naive things like Bloom filters and things like that to give you a little bit closer accuracy as to which part of the data you need to look in. But what we found is that a combination of sharding and also very specific tuning of the partition cardinality and the rows matching of inserting the data to the query pattern that you're looking for. A good example is get transaction, right? The signature, there's nothing temporal about it. There is no time that you can't look at a signature and be like, oh, that's from epoch 200, right? It's just a
Yeah,
random signature.
Could be any epoch.
Right. So you have this entire index space of every transaction that's ever been on Solana and ever could be on Solana. And so it becomes this pattern of how do we split this into an unknown variable number of buckets and still be able to access it appropriately. So you can shard the key space, basically sort it alphabetically and say, hey, split it into n number of parts and assign those to individual workloads. And I think, first principles all the way down, looking at computer science implementations, like, how fast are you supposed to be able to write to an NVMe? What does that load look like when it scales up across multiple tables, multiple shards? And never really swaying from those numbers is where we've kind of led Hydrant and got us to the point now where we have Hydrant running for a subset of Triton customers internally. We're beta testing all of the different tunabilities there, but we're seeing P50s of 9 milliseconds for get transaction. I think P99 is under 100 or 200 milliseconds right now. And these are multiple numbers, 10x, I think, better than what we've historically seen in the past.
So back up a little. So let's say I query something. So let's say I have a signature. I'm not telling from when it is, when it occurred, what the associated accounts were there. I just provide it to Clickhouse, say, all right, give me, the return on this signature. And the P9 or the P50 was
9 milliseconds.
9 milliseconds. So within 9 milliseconds, Clickhouse finds a signature in a data set of 400 terabytes.
Correct. Yeah.
All right. WTF. So how much compute is behind? Is it just like a really smart way to sort through all the data, or is there just like a quantum computer or a fleet of quantum computers handling this search?
It's a large cluster. I think right now our current cardinality is 14 nodes. Each of those nodes has 500 and some odd gigs of RAM, and I think 6 or 7 NVMEs on them. And it really is that optimization of every piece of that stack all the way up, right? So yes, we need to be tuning CPU, we need to be tuning NVMe. We've worked with our providers to get rack affinity for these servers. So all of these servers are sitting in the exact same rack. They have a single NIC at the top that they get to communicate with each other. You really have to optimize the entire stack to be able to get these kind of speeds in the performance, right? And when I say 9 milliseconds P50, it's important to remember that that's also when we're running something like 500 requests per second, right, into that system. So it's not just like, hey, this is an idle cluster that's massively over provisioned and you're able to get these numbers. This is a in production real workloads being thrown at it and still returning P50s of 9 milliseconds. And those are, those simple ones of like get transaction is pretty simple, right? If you do GSFA on the USDC mint, which the last time I checked had something like 4.5 billion unique signatures in it, we return that right now in I think 50 milliseconds. If you start paginating through it is where we start to see some of our P99s coming from. And that's just simply because one of the big filtering things that we do is that we order all of the transactions by the address that made them. So when you do GSFA, our index can already tell us exactly which server, exactly which file, exactly which part of that file it needs to start looking at.
So
right?
GFSA is get signatures for address, correct?
Correct, yes. And that's kind of like a pivot table of saying, here's an address, get me all of the transaction signatures that address was involved in.
So if you do that for USDC, which is like the most spread out token on Solana, then it has to return all the wallet addresses or private key or public keys.
Signatures. It has to return the signatures for all of the transactions that USDC has been involved in.
Right. So yeah, it's not only the token accounts, it's every transaction ever.
Yeah. Yeah. If you look in the account keys list array of a transaction and an account is listed in there, then that transaction signature will be listed in the GSFA call for that address.
All right. I'm done. That's crazy.
So it's and that table, like I mentioned, is nearing 4 trillion rows because it balloons with the number of accounts we add per transaction. But by paying that cost, by looking at this as like more of a Web 2 big data problem and not denormalizing the data, but just leaving it as it sits, we don't have to do any encoding or transaction encoding. We don't have to like give you the base 64 bytes. That's where a lot of our speed comes from, right? It's basically like take this row out of Clickhouse, shove it in this Rust struct, and stick that on the wire.
Impressive.
And then So and if we were to store this entire data set on disk, it's currently 1.1 petabytes. Clickhouse has a really awesome compression ratio. So most of our tables right now sit above a 5x compression ratio. So the entire actual compressed data set on disk is 360 terabytes, less than Old Faithful.
That's crazy. So is it like the same as Old Faithful, where when an epoch is done, we start indexing it or ingesting it, or does this happen like throughout the epoch?
That's a great question. Yeah. So Old Faithful, we were limited by the fact that we needed to really see the entire epoch in order to write that archive out, right? So that would ostensibly cause a delay. You'd have to wait for the previous epoch to be finished. With Hydrant, I was very cognizant of that being an issue. And so we built into Hydrant that ingestion pipeline. It can take from lots of different sources, but primarily gRPC, RPC streams. You could use some more common cloud databases as well, if that's where you've kept your data set from. And you can also use JetStreamer with a custom plugin that we've built and that we'll release that allows you to ingest from the Old Faithful data set directly into a Hydrant data set. And
So
then,
this will eventually also become open source.
Yes. Triton is a firm believer. One of the biggest drivers for me joining Triton was how open source they are with the technology that they build, right? It's very much part of the culture here for us to not only improve the way that we service the ecosystem, but also the way that the ecosystem can service itself, right? And I think that's where we need to get to in blockchain technology in general. So yeah, Hydrant it will be released AGPL v3. And I really hope people start to use it, get in there and tell me, hey, like this part's dumb, don't do this, and help me figure this out. Because I'll be completely honest, I would say it's probably about 35 to 50% complete AI vibe coded. Right. There's some parts where I was like, hey, I know what needs to be done here, but it's a lot of copying and pasting. You go do it. And I think that shows through in the open source repo. You'll see that we've spent a lot of time on building validation tests and stress tests and performance tests to provide some deterministic watermarks to look at and say, hey, sure, AI, you can go do your thing, but these are the metrics and things we need to see, right? You need to be able to return spec compliant responses. Go look at the mainnet endpoint and make sure that you're returning those same responses. So the confidence levels are there, and I think we've been able to prove that out in our internal testing as well.
I was going into this stream or podcast or whatever you want to call it, like, oh yeah, I know a thing or two about data sets and returns, and I'm learning so much new stuff. By the way, if you're listening live, please put your comments about bragging camp here in the comments, or your questions for Miles or myself. We would love to answer developer questions, or just if you're a Solana enthusiast. You mentioned AI and vibe coding. I know from a personal level you are pretty big on AI and vibe coding and automating stuff. Let's do a little sidestep there. What got you into AI? How long have you been using AI, and where has it brought you? And how do you see AI becoming a part of the Solana ecosystem or Solana development in general in the near future?
Yeah, so in a previous life, I used to work in fintech, Web2 fintech, and when I decided to leave that industry, I went to go look somewhere else, and I was trying to find, hey, what new technologies are cool, and I ended up working for a company that was doing early days like LLM integrations with medical data. And basically building a tool that would allow nurses and doctors to search through a patient's entire medical record to see any reasons for reversing a insurance denial claim, right? Insurance denies you, they can go back and say, no, this doctor wrote 10 years ago on this little corner here that this is a condition that existed, right? And I saw the power of that really clearly. I saw that their rates then were something like 30 hours for a 1% to 2% reversal rate, and that was just not cost effective. And when they implemented the technology, they went down to minutes and per record, and their reversal rates jumped up to 20%. And it was just insane how one little piece of technology made that much of a difference. So I could see early on that it was going to be a thing that was going to be beneficial to a lot of vertical industries, right? And just kind of rechange things. That was several years ago before I joined another Solana infrastructure company, and I was kind of lost track of it, right? And then ChatGPT came out, and that's where I got in early because I had that previous experience with kind of that early days, not what we see today, but understanding LLMs are a new thing that we need to be aware of. Yeah, and I think Trustless Engineering was one of the first AI companies on Solana, right? Back in 2024, January of 2024, we built one of like the first early LLM-based search engines for Solana. And what struck me as interesting then was like nobody cared. It wasn't a thing that really anybody cared about. And then maybe 12 to 18 months later, all of a sudden people were stoked about AI and everyone was in there. So I felt like I was just too early. So I started to kind of bide my time and really look into the technology. And I think maybe then the last month or two, especially with Codex 5.3 and Claude Code Opus 4.6, we're coming to an inflection point where if you understand the technology already, and I think that's the critical piece, you have to be able to be a mentor to the LLM and guide it and tell it when it's making the wrong decisions. But if you can do that, we're coming to this inflection point where writing code isn't what it used to be. You won't do that anymore. It won't be an efficient use of your time to do so.
So LLMs in general. I also want to make a little sidestep to X402. That's a thing, right? Yeah, X402 allows for microtransactions, maybe by an AI agent, to retrieve data, for instance, from Triton 1 or historical data. So if you want to use your agent to search, historical data on the blockchain, would that be possible with Clickhouse, Old Faithful, our infrastructure? How would that work? I know there are teams working on it.
Yes. I think X402 has the potential of being a very like frictionless interface for AI agents to access data. If it becomes widely consumed and widely used, and we don't run into some sort of protocol war with every chain implementing it slightly different, right? I think it makes a lot of sense for being able to have permissionless access to the data. One thing I haven't been convinced on yet is just because somebody pays you, does that mean they should be able to DOS your system, right? And so how do you implement that checks and balances at like a rate limit level or something like that? And I think Triton's teams internally, without giving out too much information away, I think we've come up with a pretty decent solution for that. And so, yeah, I think even without needing an account, although I highly suggest everyone does have a Triton account, without needing an account, you could ostensibly have your AI agent provide itself with more context automatically, right? Being able to understand these APIs just exist, maybe even wrapping them in a tool for the agent to use. All of those things become, I think, table stakes for AI agents, right? But we're also at a point now where I don't use MCPs. I don't really use a lot of tools. The agent itself has become intelligent enough to use the existing tools I already have on the system that I have it installed in, right? I don't need it to install some web browsing tool. Just use Playwright that's already there, right? Or use the CLI for cargo format or Clippy or things like that. You don't need to come up with your own formatting. So really treating it like a developer, telling it, hey, this is how I would do it if I was you and you have access to everything all the tools that I would use to use it, has really guided it in the right place to not need that data up front. And so being able to access it on demand is definitely going to be a good thing.
Oh, damn. What a time to be alive.
Yeah. I also noticed that I think YubiKey is coming out with a new version of their device that allows on-device signing, which I think is going to be really critical and maybe being slept on by the ecosystem in the fact that you can provide high-level credentials to an agent at runtime in an API key, but still require a human in the loop interaction at the time of use by having a UB key that requires you to touch it and sign that one-time use transaction key and accessibility, right? I think that something like that would be really powerful for people to use, especially since everyone seems to have gone out and bought a Mac Mini to run their shell scripts on. But yeah,
Yeah, it's I believe there's a huge demand right now. It's crazy. All right, awesome. So let's circle back to ClickHouse. What would be important for developers to know about how to use it? I mean, our developer interfaces make it real easy. You could just make JSON RPC requests to your Trident 1 endpoint. What are considerations? What would be, how do
yeah.
you handle this efficiently and integrate it into your protocol as a developer if, as most efficiently? Because I know there are ways to make it really expensive for yourself, make it really ineffective. Tell us a little bit about that.
Yeah, so one of the great things about ClickHouse is that it's fairly agnostic about where the data can actually live, right? ClickHouse Cloud has a fairly good product that you can use as a backing service for it if you so desire. Um, it's all going to depend on what data you want to keep, right? A provider like Triton, we have an obligation to keep everything. And so we do, and our infrastructure is scaled to that point. One easy thing that you can do is just not include votes. If you don't have any business need for votes at all, you can add a filter to Hydrant when you're ingesting to don't include votes, and that will cut your data dramatically just by that. And then take that further. Go to first principles. Look at your business layer. What do you really need? Are you doing DeFi? Okay, cool. Maybe you only need to index DeFi accounts and programs, right? You don't need to ingest everything. And the ability to have this ingest pipeline where you can go and backfill the data from old faithful archives or wherever you might have means that you don't have to do it all up front, right? Take what you need at first, and if you need to go add a couple more programs, you can just do another backfill and ingest those additional programs. If you do it that way, it's going to be really, really light, right? Our current bottleneck is disk IO, and we use NVMe spread out across multiple nodes. So we do a fairly good job of load balancing it, but there are still some hot accounts and parts of the disk that get hit. It's all going to depend on your workload. I suggest using ClickHouse and Docker to start with. When you download the Hydrant repo, we have a very easy quick start for you to get it up and running. If you're running it on a system, with say more than 2 terabytes of disk space and 128 gigs of RAM, you could just run it from that. It's a 2-line command. It'll run. Go ahead and get started. It'll probably be fine for several epochs.
Nice. Man, it's exciting to go through multiple iterations of the same problem. Uh, as long as I've been working with Trident 1, I've seen like this project or this problem go through so many phases and so many solutions. How do you feel this solution we currently have? Like first this was all the hype, then it was Old Faithful is going to solve all our issues. Now it's ClickHouse. How will this scale moving forward? Because you told us there's going to be some ballooning because your index or you're storing more data than actually the raw data. So with the upcoming upgrades, increasing the block sizes, stuff like that. Pinocchio even more efficiently write transactions, basically, reducing the transaction size, so there's room for more transactions in every block. How do you feel this is going to scale, and how will this scale 5 years from now?
Yeah, great questions. I think, and I wanted to do correct one thing you said there is I think we're actually getting ready to increase transaction size. So we'll have even bigger transactions per block, right? And we'll have bigger blocks. I think I've seen 100 million CU get thrown around by some crazy people too. So yeah, the IBRL is alive and well. And I think Clickhouse is very much in service, right? There you go. Clickhouse is very much in service of the reducing the latency side of that equation, right? Is how do we get access to that data as fast as possible so that we can make better informed decisions at near real-time speed. Clickhouse is very well serviced for this, and the way that we've architected the sharding, it's very simple. Like we can add, if we need to increase the write rates, we can add more shards. If we need to increase the read rates, we can add more replicas behind each shard. So I'm not too concerned really about what the next 5 years look for us for that storage. I think that we've baked that in.
All right, nice. So are we working together? Are we in contact with the ClickHouse team? Do they know what we're building on top of their architecture, basically?
I don't believe they do. I think maybe just tangentially that they might have heard about us, but at least during our development process, we didn't really work like hand in hand with them or anything. It's got just absolutely massive developer documentation that is pretty easy. And again, LLMs, right? It's like you can start asking those questions, and if you're inquisitive about them, you can usually find the answer, or it'll point you to the documentation where it exists.
All right. Apollo Server asks, what will be the ClickHouse limitations?
Yeah, so I think, and we didn't really answer this in the question where you asked about it, Steve, and I apologize for that. But one of the things that's really nice about this Hydrant implementation, at least in our testing, is that when you're running the gRPC tip ingestion, it's going to connect to a Dragon's Mouth endpoint, grab that data as fast as it sees it, and stick it into ClickHouse. In practice, we've seen that in order to actually send a query to Hydrant and get that same data back, you're looking about a 4-slot delay, right? So it'll take about 4 slots before you actually see it come back in a query. Much better than a whole epoch, which is what we were talking about with Old Faithful, right? But it's still not, if you do a GSFA, you expect every signature that address has been in.
Especially if
right? You don't want.
Yeah, especially if it's already 1.5 seconds in the past. I mean, that's an era on Solana.
Exactly. Yeah. So Hydrant does have what we've called the head cache built into it, and it's an optional feature. You don't have to run it if you don't want to. Hydrant runs by itself with about 60 megabytes of working set memory if you do not have the head cache enabled. Like I mentioned before, it's literally just to grab the rows out of ClickHouse and send them as fast as they can. So it's very, very performant. You can run it in the smallest VM that you have. If you have the head cache enabled, what it does is it will connect to that gRPC stream and start listening for processed blocks. And we use another project by a wonderful team inside of Triton, the block machine. That's a Rust crate that takes care of all of the complex logic of watching for process blocks and determining whether they've been forked or not. And then just providing us a real easy interface to say, okay, here's the processed and finalized blocks, processed and confirmed blocks for the last n number of epochs. And in practice, that's about 100. And then everything else is stored in ClickHouse, right? So when you make a query for, let's say, GSFA, we're going to go and get all of the addresses out of the head cache first. If that satisfies your request, we'll send it back right there, not even talk to ClickHouse. If it doesn't, and we need more addresses, then we'll just query ClickHouse for those remaining addresses. So with Hydrant head cache and ClickHouse combined, you have tip to Genesis access in 9 milliseconds.
9 milliseconds on the P50. So that's the 50%.
On the P50. Yeah.
On the P90.
On the P90, I believe we're at 80 milliseconds. Yeah.
Wow.
And P99 is the one that we're at 191 last time I checked. So 99% of all requests, any shape that you can send to ClickHouse, we're sending back in under 200 milliseconds. And those high P99 queries are going to be the ones where they're querying USDC Mint, and it's going from, they're saying, hey, give me every signature for USDC Mint before this signature. So we have to go find the location of that random signature somewhere in these 4.5 billion signatures for that one address, and then get you the ones after it or before it, right? And that's
Yeah.
where a lot of that index searching happens. So
If you're listening in and you want to try this, make sure you run a really powerful backend with amazing connectivity, because if you run this on a potato, it's not going to come on your screen in 9 milliseconds. It's going to take a while, crocodile.
absolutely, yeah. And if you start up the dev environment with the defaults, it connects to the public API mainnet endpoint, which you get rate limited massively there. You'll see 1 block a second come through. That is not going to be efficient. Read through the docs, look at how to run Jetstreamer, and you'll get several 100,000 or 1 million transactions per second into ClickHouse, no problem, on a standard AWS, 3264 gigabyte VM.
All right. So this is all partly live. It's in beta. We're running it right now. For the people who want to query stuff now, we also do that. But it might not or might go to any of our storages of Ledger.
That is correct. Yeah, don't go to Triton and sign up for an account and make a whole bunch of get transactions and GSFA requests and say, oh, this isn't Miles is a liar. This isn't what we're finding. We run infrastructure in many different geographical regions, and we have very advanced routing that allows us to take segments of traffic based upon customer or where their location is or any other different metric, and shift it to different systems. And so that's what we're doing now. I will say that like most of our traffic that we're testing on ClickHouse is coming from a subset of each region. So I do believe we have EU, US, AP, all three have some subset of their traffic being sent to our hydrant. Yeah.
Nice. So does SOL stand for storage of ledger or speed of light?
Oh man, I'm not gonna take sides on that one. I like both parties.
All right, cool. So let's see. Um, I think I learned all there is to know about ClickHouse and the storage of Solana's ledger in any way, shape, or form. So depending on how you compress it and everything else, it's about half a petabyte, just under.
Yeah, the
Um,
last time I checked at the on disk size, we were like 360 terabytes, right? Um, One of the great things about like ClickHouse and its compression is, like we mentioned before, for GSFA, we store on disk every row in that table by the order of the address that signature is for. Well, we don't need to store that entire byte array for every row. We can just say store it once and then say, hey, the next 15 million rows are that same record, right? So that right there gives us a massive compression ratio.
nice.
There are other things like logs and things like that we can apply high compression to a specific column, right? And that all of those combined, really going through every single field and identifying what the tuning, the optimal tuning for each field at the large data set that we have in Solana is going to be, was what took us, 8 months to get to this process.
All right, awesome. So I think we learned all there is to know about finding needles in a haystack of needles. Any final thoughts you want to add? Um, Anything you want to share with starting developers on Solana? Any insight? Any wise words before we end the stream?
Yeah, I think go boldly into that dark night. right? Like it just because it's confusing and frustrating, the things that are worth doing are going to be hard. And Solana is definitely one of those things. I think we've seen it proven out time and time again that the technology is sound, and it is the most performant that I've seen. And being pragmatic about those problems that come up and exist. Ledger was a problem. And so we sat down and we chewed glass for several months and came out with a solution to it. And if you find a better one, please do that too, because we just want to make the system better, right? Yeah, Hydrant is going to be open sourced here. My hope is before the end of February, but we got some cleanup to do internally, make sure that all the ducks are in a row, and I really want to get people to give some input on it, right?
All right. Awesome. Thanks so much. Yeah, and I hope to see everyone watching next week as well. And for now, this was it. Pirates Parley, episode 5. Next week with a new mic. The sound quality is going to be so much better. All
You
right.
sound good to me.
Well, you sound good to me and you look nice too.
Hey.
Hey. All right. Thanks, everyone.